Hi everyone! What we're going to be working on in today's lesson are the sum and difference identities. So basically, we're going to be asking you to calculate values, the sine, the cosine, or the tangent of angles that are not our special angles. So it's not going to be 30, 45, 60, 90, 120, and so on. It's not going to be those special angles that are on our unit circle. But they're going to be angles that can be calculated using two of those special angles either being added or subtracted. So we have three formulas that we'll be working with, and one's for cosine, one's for sine, and one's for tangent. So let's go ahead and let's see what we have here. So the first one I'm going to talk about is the formula for sum and difference of cosine. So what we have is the cosine of alpha plus or minus beta. In other words, two angles that are being added or subtracted from each other. Looks like this. The cosine of the first angle times the cosine of the second angle minus or plus, and I'll talk about that in a second, the sine of the first angle times the sine of the second angle. Now, it's very important that you realize whatever sign you have here is going to be the opposite of what you use in your formula. Okay, so that's going to be super, super important. And you're going to see what I mean in a moment. So look at what we have for our example. Our example says that we are to use the sum or difference identity for cosine to find the exact value of the cosine of 75. So we have to think about our special angles and how we might get 75 by either adding or subtracting them. So again, think of these angles, okay, 30, 45, 60, 90, 120, 135, and so on and so on and so on, all the way around the circle, right? We're not going to go forever here. 180. How can we get these two of these angles to either add to 75 or subtract to equal 75? Well, to me, the easiest one is to take 45 plus 30. Okay, that to me is the easiest one. But maybe you're someone who said, oh, but 135 minus 60 is also 70. Okay, 135 minus 60 is also 70. That would be another way to get 75. And of course, we know the sine and cosine of all of these angles. So I'm going to go ahead and use the addition equation. So what we're going to have is the cosine of 45 plus 30. Okay, so 45 plus 30. And I'm going to write it out this time. It's going to equal the cosine of 45 times the cosine of 30. And here's what I was talking about. Because this is addition here, we will use subtraction here. Sine of 45 times the sine of 30. Now, remember how I told you that unit circle is never going away? I think you're starting to believe me now, because here we go again. Here's 45. Here's 30. Okay, and let's take a look at what we have here. So we have cosine of 45. Well, hopefully you remember that that's root 2 over 2 times the cosine of 30. So cosine, remember, is our x value. 30 is a longer triangle. It's not so tall. Minus the sine of 45, which is right here, root 2 over 2, times the sine of 30, which is a little short triangle, and that's 1/2. And now we just put it all together. Root 3 times root 2 is root 6 over 2 times 2 is 4, minus root 2 over 4. And they have the same denominator, so we express them as a fraction, root 6 minus root 2 over 4. That is the exact value of the cosine of 75. Now, if we chose to use 135 and 60 and subtracted, we would have gotten the same answer. Okay, absolutely would have gotten the same answer. Okay, so that's a pretty straightforward formula. Let's take a look at the second one, which is sum and difference for a sine equation. So this is, it's a similar equation, not the same, of course. So the sine of two angles being added or subtracted will look like this. The sine of the first angle times the cosine of the second angle plus or minus the cosine of the second angle times cosine of the first angle times the sine of the second angle. And did you notice that these signs are the same? Okay, those are exactly the same. So, in the example that I've given you, I'm looking for you to calculate the sine of 105. So, what are you thinking? Maybe you've come up with 60 and 45 add up to 105. That's probably the most obvious. So let's go ahead and use this example. Let's use 60 and 45. So our signs are going to be the same. We will have the sine of 60 plus 45 equals the sine of the first angle times the cosine of the second angle, right? Sine of 60 times cosine of 45 plus the cosine of 60 times the sine of 45. Now again, that unit circle. Here's our 60-degree angle. It's taller than it is wide. And our 45 we just did, so hopefully you remember that. So let's go ahead and put our values in. So the sine of 60, the height of a 60-degree angle, root 3 over 2, times the cosine of 45. Cosine is like the width, so it's root 2 over 2, plus, now we've got the cosine of 60, so that's that, not very wide, so it's 1/2, times the sine of 45, which is root 2 over 2. Let's put it all together. Notice that both denominators will be 4. So if we want, we can jump right to that. And we can say root 6 plus root 2. And you might be thinking that looks a lot like the previous answer. Well, the other answer had subtraction in it, so they are different values. Okay, and we get a lot of root 6s and root 2s. Just the nature of this is that we're using those special angles over and over again. So we kind of get a lot of values that look similar. Okay, so the third equation, the third formula that we have is for tangent. And this one is a little bit more complicated, but not too bad. So we're going to have the tangent of two angles being added or subtracted. Okay, and this one's going to wind up being a big fraction. So it's the tangent of the first angle plus or minus the tangent of the second angle. So notice these signs are the same, aren't they? And our denominator, it will be 1 minus or plus, so the signs are opposite, the tangent of the first angle times the tangent of the second angle. So not too bad. Okay, let me erase all this nonsense that I have there. And let's look at my example. So the example that I have here is the tangent of 255. So you might be thinking, I know 210 plus 45 equals 255, and that would certainly work. Or I could do 300 minus 45, and that would also work. So I'm going to tell you right now, I actually did it in my notes with the addition one, but I want us to do a subtraction together. So we're going to do this one together. as I said, you would get the same answer no matter which one you use, but we're going to use the tangent of 300 minus 45. So what does that look like? Tangent of 300 minus 45, okay, which is the tangent of 255, equals the tangent of 300 minus the tangent of 45. Again, those signs are the same in the numerator, over 1 plus the tangent of 300 times the tangent of 45. So here's what I'd like for you to do. I'd like for you to pause this video, okay, thinking about these triangles, okay, our 300 degree is going to be here, and our 45 hasn't changed. We've used that in all of these examples, is here. I'd love for you to drop those numbers in and see if you drop the numbers in correctly, and then we can work that out together. So go ahead and pause this video and see if you can drop the right values in there. All right, let's see how you did. So I like to set it up with the signs at the beginning because then I don't have to think about them and I just have to worry about my triangle. So that might be a little thing to help you out. So the tangent of 300, remember 300 has a 60-degree angle. All students take calculus, so tangent is negative here. So you should have gotten negative root 3 minus, and now the tangent of a 45-degree angle, those two sides are congruent, so that's 1. And then we have 1 plus negative root 3 times 1. Well, we're going to have to clean this up. So first thing I'm going to do is just a little rewrite. So we have negative root 3 minus 1 over 1 minus root 3. And you may recall that one of the rules that we have is that we cannot have a radical in our denominator. So we're going to have to multiply this fraction by something to eliminate the value in the denominator, but not to change the value of the fraction. So we will multiply by the conjugate. Remember, conjugate, it's like the binomials are the same, except for one has plus and one has minus. So we're going to multiply by 1 plus the square root of 3 over 1 plus the square root of 3. That won't change the value of our fraction. It's just going to change what it looks like. So in our numerator, we must FOIL. So let's take a look. Negative root 3 times 1 gives us negative root 3. Negative root 3 times root 3 gives us minus 3. On the inside here, we have negative 1 times 1 is minus 1. And then negative 1 times root 3 gives us minus root 3. In our denominator, we have 1 by 1 is 1. Outer and inner are going to cancel each other out, so I'm not even doing them. Negative root 3 times positive root 3 gives us minus 3. So we need to simplify this a little bit. Let's take a look. We have a numerator where we have negative root 3 minus root 3. Well, that means we have negative 2 root 3. Negative 3 minus 1 gives us minus 4. And that's all over negative 2. And if you look, if we can simplify everything by a certain value, we're allowed to do that. And these are all divisible by negative 2. So let's divide everything by negative 2, and we get root 3 plus 2. And that is the exact value of the tangent of 225. Okay, so this formula is going to be a little bit more complicated just because you're going to have to rationalize sometimes and you're going to have to possibly FOIL some things out, but that's, we're good at that. We know how to do that. Okay, one more. This is kind of a special property special example, because this kind of brings together what we've just done with looking at identities and verifying identities, which we just finished doing. So looking at this, we're told to verify that the secant of pi plus a equals the opposite of the secant of a. So seeing that we have this, okay, that looks like addition. Let's talk about secant. Secant is the reciprocal of cosine, isn't it? So what I suggest is that we keep this right side and we work on using the left side. So the first thing that I would do is I would say, well, secant, I'm going to rewrite that as 1 over the cosine of pi plus a. Now, you just got a formula for the cosine of two angles being added together. So we're going to expand this using that formula. And what we would get would be 1 over, making a big fraction here, the cosine of pi times the cosine of a minus, because remember the first formula we got, those signs were opposite, the sine of pi times the sine of a. Okay, we've expanded this using that sum formula for cosine. Now we have to drop our values in. So we will have 1 over, now you have to think, all right, I'm going to think over here. Let's see. Pi is here. Well, what is the cosine of pi? Well, I hope you remember that it's -1 times the cosine of a. We don't know what a is. A could be any angle. We have no idea. Minus, all right, what's the sine of pi? Well, the height over here at pi is 0 times the sine of a. Well, 0 times anything is 0. And we essentially have 1 over negative cosine of a, which means we can bring that cosine of a to the top. In fact, we can bring all of it to the top. And what it becomes is negative secant of a equals negative secant of a. We verified this to be an identity. It is true. And we used our new formula to do that. So how awesome is that? I'm not sure if you think it's as awesome as I do. Anyway, have a great day, everybody.